Okay, so the solutions to this exercise, I'll work through now. Obviously, it's important that you try this exercise first, okay, before you actually look at these solutions, alright? Otherwise, you're not going to gain anything. So, with the first one, you've got y equals e to the power 9 minus 2x, okay? So when you differentiate this, of course, e stays the same, doesn't it? So you get the same, but then you times it then by the derivative here. If you differentiate this, you just get minus 2. So you're timesing it by minus 2. The answer then becomes minus 2 e to the power 9 minus 2x. Okay, so that's the first one done for you. Second one, you've got a quotient rule, if you notice. Okay, so the second one you've got y equals ln x over x squared. So this is a quotient rule. So your top function is the u, the bottom function is the x squared. So du dx then, okay, differentiate this, you get 1 over x. dv dx, differentiate that, you get 2x, okay. So then using the quotient rule, you crisscross, so dy dx, okay, where the quotient rule is v du dx, that times that. Take away, obviously then, u dv dx, so that times that. All over v squared, so you're going to have to square that. Alright, so some simplifying needing to happen here with this one. You've got x squared over x. It's just x, isn't it? If you think about it, that x will cancel with that power there, so you effectively that becomes power 1. So you have x take away 2x ln x, and on the bottom x squared to the power 2. When one power is raised to another power, you multiply them. So that's x to the power 4. Okay, so we've actually used two rules of indices there, haven't we? We used the rule here. We've got x squared on the top, x on the bottom. So you take away the powers. So 2 take away 1 is 1. Okay, so that's why we've got that there. And here we've got one power raised to another, becomes x to the power 4. On the top then, factorize out. Okay, so you have x. Okay, x is a factor on the top, so you can take out x. So you have 1 minus 2 ln x, and on the bottom you have x to the power 4. Okay, and again we can use this idea where that x will cancel with this here, so it becomes a power 3. So you end up having 1 minus 2 ln x over x cubed. It is important to simplify, because that's what they ask for in the exam. Okay, question 3. Y equals tan 5x squared plus 3. Okay, now in this case it's just a function of a function, yeah, because it's tan of, yeah, this bracket here means tan of this. So you need to remember what tan becomes. It's in, as I said, it's in the formula booklet earlier on, it's in the formula booklet. Tan becomes sec squared, isn't it? Sec squared of all of this. And then you've got a times then by the derivative in there, and that's just simply 10x. Okay, so that's your answer there. And you could write the 10x at the front. Okay, and there's your answer. Part 4, again, function of a function. So dy dx, okay, differentiate the outside function, which is ln, so it'll be 1 over it, 1 over cos x, times then the derivative of that. Differentiate cos, you get minus sine x, so that's minus sine over cos. And if you think about it, sine over cos is tan, isn't it? Okay, so that will be minus tan x. Okay, part 5, product. Okay, so product, you're multiplying x squared by tan to the minus 1 of x. So your product, u will be x squared, v will be tan to the minus 1 of x, du dx will be 2x, dv dx will be 1 over 1 plus x squared. Okay, so when you use the product rule then, you have dy dx equals that times that, this times this, so that times that will be 2x tan to the minus 1 of x, plus then this times this, will be x squared over 1 plus x squared. Okay, so you could leave it like that. You could even take an x out if you wanted to, because x, if you notice, x is a common factor. Okay, you could sort of finish it like that if you wanted to. Okay, question 6. Y equals e to the power of 6x all over 3x plus 2 to the power 4. Okay, now in this case you've got a quotient rule. Okay, one function divided by another. So u will equal e to the 6x, v will equal 3x plus 2 all to the power 4. So your du dx, differentiate this, and remember e to the 6x stays the same when you differentiate it. You times it then by the derivative of this, which is just 6. So you end up having this new 6e to the 6x. dv dx, okay, bring the power down, again function of a function, bring it down. That reduces to 3, and then you times it by the derivative inside, which is 3. So that becomes 4 times 3, which is 12. So the quotient rule then is this times this, this times this. So you've got this times that, so it'd be 6e to the 6x bracket 3x plus 2 to the power 4. Okay. Take away, of course, so it's v du dx, take away u dv dx, so take away this times this. So this times this will be 12 e to the 6x bracket 3x plus 2 all cubed, all over v squared. So that's your v. And of course we need to square this, so you know, maybe use a square bracket if you want, so it doesn't get too confusing. Now on the top there, what we need to do now is try and simplify this. The best way is just to factorize. If you notice, there's common factors here. 6, for instance, you've got 6 here, and you've got 12 there, so 6 is a common factor. E to the 6x is common to both. And also notice the bracket is common to both, 3x plus 2. And when I factorize it, I take out the smallest power, so you've got 4 there, 3 there, so I'll take out cubed. And now you could see that this here goes into that, and this also goes into all of that. So what I'm going to do now is I'm going to do a square bracket just so it's clear for you. You've got to ask yourself, what do I times by this to get this? And of course you've already got that bit here. You just need the bracket to the power 4, so I need to times it by another 3x plus 2. That will make it to the power 4. Take away then, well, what do I times by this to get that? Well, e to the 6x is already there, but I need it to be 12, so I've got to times it by 2. And the bracket cubed is already there, so that's sorted for me. So I've got that there, and what you'll notice nicely is in this big bracket now, I got 3x plus 2, take away 2, so they just vanish, don't they? Plus 2, take away 2 vanishes. And it's all over then as well. Remember, one power raised to another, you times them, so it'll be 3x plus 2 to the power 8. So when I simplify it, you've got in here then 3x. Okay, that's all you've got is 3x, so maybe bring that to the front. So I end up having 18x e to the 6x bracket 3x plus 2 cubed all over 3x plus 2 to bracket 8. And then even better, this cubed here, this thing, the whole thing will we'll be able to divide through. Same on the bottom, of course, because you've lost 3 powers there, you're going to lose 3 powers here, so that'll be to the power 5, and you're done. Okay, so you end up having 18x e to the 6x over 3x plus 2 to the power 5. Okay, and there's your answer. Okay, question 7, right? You look at this now and you wonder what are we meant to do here? Is it a quotient? It can be thought of as a quotient, I suppose, because you've got one function divided by another, but because there's just one, my advice to you is just to take this up, okay, take it up, it'll be much easier. Now before you take it up, we need to write this cube root as a power. So of course don't forget cube root is the power third. Okay, that's what a cube root is, the power third. Take it up, that's what I would do, because it's much easier then if you treat it that way. It's much easier to differentiate. You can just now take this as a function of a function. So you do by dx, bring that minus third down, 8 minus 5x to the power 4. Take away 1 from that, you get minus 4 thirds, times then the derivative in here, which is minus 20 x cubed. So your answer then will be, well, if you look now, you've got a minus and a minus, that becomes a plus. Okay, minus times a minus is a plus. You've got 20x cubed on the top. On the bottom you've got 3, and you can take this down as well, and 8 minus 5x to the power 4, all to the power 4 thirds. Okay, question 8. Y equals 3 plus sine x, 2 plus cos x. Okay, so here you've got quotient rule. Okay, so u will equal 3 plus sine x, v will equal 2 plus cos x. So du dx, differentiate this, you get cos x. Okay, because 3 disappears, sine x becomes cos x. Differentiate this, 2 disappears, cos x becomes minus sine x. So using the quotient rule, you got that times this. Take away this times this. All over that squared, b squared. So then when you expand this then, cos x times 2 is 2 cos x. Cos x times cos x is cos squared x. You've got two minuses of course, become a plus. So you've got sin x times 3 is plus 3 sin x. And you've got sin x times sin x is sin squared x. All over the bottom. And with the bottom of course, just leave it, right? Don't multiply it out, there's no need to. With the top, but you might notice now, right? You might see that if I write it like this, just rearranging them around, you might notice on the top here, look, sine squared and cos squared, of course, goes back to C2 work, that equals 1. So my final answer is 2 cos x plus 3 sin x plus 1 over 2 plus cos x all squared. Okay, so a little mistake there, it shouldn't be squared. I got that from here, and that's your answer. Okay, we got rid of that by making it 1, and that's the final answer. Okay, last one. Okay, question 9. By first writing cot x as cos of a sine, show that d by dx of cot x is minus cos 6 squared x. And remember, this is a result in your formula booklet, okay? But sometimes they'll ask you to prove it. So if we've got y equals cot x, we want to prove that the derivative is that. So they say, first of all, write it as cos x over sine x, okay, which is what cot x is. So of course then you've got your quotient rule. Okay, quotient, you've got one function divided by another, u is cos, v is sine. So du dx is minus sine x, dv dx is cos x. Use your quotient rule, so dy dx, that times that, so that'll be minus sine squared x, okay, when you times that by that. Take away then u dv dx, which is cos x times cos x, which is cos squared x. All over then v squared, which is sine squared x. What I'm hoping you notice on the top, you've actually got a common factor of minus 1, haven't you? Because minus minus, you could write it like this. You could take out that minus 1, and then put it in a bracket like that. Okay. So nothing wrong with that, isn't there? If you think about it, take the minus through, you're back to that. And what's great about this then is sine squared plus cos squared you know is 1. Okay, so that's minus 1 over sine squared x. Okay, now 1 over sine is cosec. 1 over sine squared will be cosec squared x, and of course there's a minus in front. So we get our solution.